Missed the part where you chose the visualization parameter.
Yes, yes, we also change it.
You need to read that again.
Okay, so we find out this type of map of NDVI. Okay, but this NDVI map have a problem. Suppose I show you for the Columbia, just run. Okay, this problem is that if you check the pixel value, suppose if I just click on the Inspector tab and click on this map, it show you this type of value. You can see 5634.17. We find out this type of value, but NDVI range -1 to +1. So now we need to reproject the scale value. Okay, reproject this scale value, then we find out the proper NDVI value. Okay, range will be -1 to +1, otherwise show this type of result 3554. So let's go try to reproject this scale of NDVI value. So now here I have total 23 images. Okay, this 23 images I need to multiply with my scale value. Okay, then I find out that reprojected result, then I can easily apply it, and then we can get the result. So you can check this what is the scale value. So scale value basically find out, you can see this is the scale value. So this type of scale value we need to multiply with all of images. Okay, then we find out this reprojected scale value result. So basically for the modis, when you find out this type of scale value, try to use it to get the more better pixel. Okay, for the modis LST, modis, any modis dataset, you find out this type of scale value. Okay, as well as for the Sentinel-1 or Landsat have also a scale value or offset value. So this type of value, when you multiply, then you find out the more better pixel value. Okay, so in this case NDVI scalable is the 0.001. This value need to multiply total 23 images. Okay, so now at the same time I create a function. This function help me to multiply all of images 0.001 at the same time. Okay, so let's go try to use the concept of function. Same concept we also use in here, and then show the result. So let's go. So just write the code. Take a variable. You can put any name as a variable. Suppose scaled NDVI, and put the function keyword. Okay, function keyword. Put the element name. I put the element name, suppose img, and then as you can put any name as the element. I put the img. After that, just put the curly bracket. In this curly bracket, put your argument, what you need using this element. So in this case, what I return from this function, I want to return this function. I want to return this function multiply this value 0.0001. Okay, so in this case I take only for the one element. Okay, one element, mainly one image I take, but I have also rest of 22 images. For that, what can I do? So for rest of the other images, we have to use a function. It's called the copy properties. Properties. Just I copy the properties after multiply, and these properties I apply system time start to system time end. Okay, so this function I again explain. First of all, just take a variable name of your function, equal sign, function keyword. I take only for the one element. Okay, only for the one element means then only for the one image, and this image I return multiply with the scale factor. But I have also rest of other images. So for that, I copy the properties after multiplication with this value 0.001, and then it applies system time start to system time end. System time start to system time end, it means that in my system, in my code, I already defined the start time and end time. Basically, this start and end time, between this time period, we find out the total 23 images. So when I apply this system time start to system time end, it including in the time frame all of images, total 23 images I multiply. So this is the function. Okay, and this function we need to always connect with our collection, mainly image collection. So this is the function. This function you need to connect with the image collection. Image collection basically 23 images. It is stored in this variable modis dataset. So just simply copy and paste here. And for connecting, just use here the map function for connecting. Use the parenthesis and also close the parenthesis. Okay. So now if I check, suppose just print the scale NDVI, how much image, we find out the same number of image collection, but now this number of image collection is reprojected the scale value 23. Okay, so now further I want to use this collection and compute the average NDVI, compute the average NDVI, and now run the code. So it shows as a white color. Okay, so now I need to change the mean and max value. It's the default 0 and 8000, but for my study area, suppose I choose the random -1 to +1. I put it, just run it. Okay, you can see this visualization is not much good. Suppose I want to put my own color combination. I put here, suppose just make the list of color plated. For that, blue color, blue, then put here suppose, then put here suppose a white color, then put here the green color. For I put only for the 3 color combination, blue, white and green, and now run the code. Okay, it show this type of result, this map. But when you stressing this data, then we find out the more better. Suppose I just stress the data 98%, and it automatically show this type of, so just I copy this mean value and change it, and also put here 0.8, copy and paste here, then apply. So now this stressing level is also added in my code. So now we can easily identify more better map. Okay, green is indicating about the vegetation, blue is indicating about the water body, okay, white is indicating about the other types of feature. You can also check the value. Suppose click on the next tab and click. So now I find out the 0.8. Okay, dense vegetation I find out for this coordinate. Suppose if I just click on here, okay, click on here, 0.6, 0.8. Okay, so we find out this type of mapping. Suppose I need to check it for another one. Suppose I put here for Australia, click run. So can you show this type of totally blue color? Okay, because this mean and max is not as adjust for this boundary. So you can again check. Okay, just put here, click on here, and I put the blue color, so that's why it look like that. So if I stressing and then check, and without blue color I simply put here, suppose I think it will be more better if I put here, suppose this type of color, just apply. Right, so now you find out this type of place, we find out the vegetation, green color indicating about the vegetation. Okay, other is the desert. Check the value. Okay, so check for that, click to run. Okay, so we find out this type of place is the vegetation. Or any other color combination you can easily apply in here. Okay, so I can see, find out. For water body, find out the negative pixel of NDVI. Okay, so this is the map. Okay, just reproject it, scale value, then you find out that range -1 to +1. Or if you want to check for the Barcuna face, so just let me check. Just stressing the data to get the more better result. Just apply. So now you find out this type of map for this country. Okay, blue is indicating about the water body, and this type of things indicating about the vegetation. If you simply zoom, so you can see this is the water body. Water body pixel value show the negative pixel. Okay, and positive, high positive value indicating about the high dense vegetation. Okay, and low positive value indicating about the sparse vegetation. Okay, so now how I can export this type of map? Okay, suppose this map I want to export from here, and further we need to use the ArcMap software or QGIS software to create the map layout for our research paper or presentation. So I'll just show you this type of process for the 5th number class. So now how I can export it? For exporting, we always use the same code for exporting any imagery. Okay, suppose I want to export this map. So for that, simply search here, export, and you can see we find out the 1 2 3 4 types of export option. Okay, so 4 types of export option, but currently this is the red color basically deprecated. Okay, so use at the export image to drive instead of this function export image. Okay, so now 3, suppose asset tab, cloud storage, and image to drive. So asset tab basically, suppose this data or this file I want to export tab in my asset tab. So further this file I can apply for other analysis. Okay, I can easily apply the other. Suppose this imagery, this NDVI map I want to export and store in the asset tab. So then we need to use the function to asset cloud storage. So cloud storage basically Google Earth Engine. We can also, when you are using the paid version, then we can easily use their cloud storage, and we can also upload this map easily in the cloud, and freely Google Drive we can easily export in our Google Drive, and from the Google Drive we can easily download it. Okay, so now export image to drive, this function I need to use. So just click on here. So you cannot see this type of arrow sign in your code editor. So for that you need to install the extension. Okay, it's called the Google Earth Engine Chrome extension. Okay, also try to install it, Google Earth Engine Chrome extension. Okay, so Google Earth Engine, you can see different types of extension. It's a one kind of extension, or you can see this type of extension you can simply install. Okay, so in this case Google Earth Engine extension you can see. Okay, just simply go to the Google Chrome website, extension, just simply down search the Google Earth Engine, then you can also get this type of benefit. You can see this type of arrow sign. If I just click on the arrow sign, you can see what happened. It automatically including all of argument in my code editor. So now I can simply put in here. So you can see export image to drive, basically it's help you to export the image, GeoTIFF file image in your Google Drive. Okay, and first argument is the image basically which layer you want to export. I want to export this layer. Okay, I want to export this layer, I want to export this map. Okay, and this map is already stored in a variable. Just find out the variable name and then write in here. So this variable name is that NDVI map, because you can see when I use the map.add layer and apply the NDVI map, then this map is loaded. So just I copy this name, because this name is stored in this map. Just paste here. Oh, sorry. Just copy this name and paste here. So now description, it can be anything. We can put anything without a space. We can put any name. I put the name, suppose Burkina Faso NDVI. You can put any name, and then uncomment it not need. Folder, you can put any name as a folder. When you just use the name, it automatically create a folder in your Google Drive. Suppose I put the folder name is that 29 mess. You can put any name as a folder without a space. Without a space, you can simply use the underscore. There is no problem. File name prefix is not need. Just I remove it, not need. Region, it's very important in your study area. Region, basically your shapefile variable name. Shapefile variable name, it is stored in the ROI. You can say ROI. This Burkina Faso, this study area is stored in the ROI. Just I copy the ROI and then use here. Then a scale. A scale is the resolution of your satellite imagery. So in this case, this resolution is the 250 meters. Just use it. 250 meters. 250 meters. Then CRS score, it's not need. It's not need. It's not need. Max pixel. Max pixel is need when you face some problem. Okay. Suppose sometime we face the problem when you work with big study area. Sometimes you find out that there is a lot of pixel. That's why it's not exported. Then we need to use the max pixel. But otherwise, max pixel is not need. First of all, you try without max pixel. Okay. Then face any problem, then try to use the max pixel. Max pixel value basically 1E13. It's the highest value. 1E13 means that 1 into 10 to the 13. Okay. Try to use it, then it will work. Okay. But not all time. When you face the problem, then try it. Otherwise, not need. Okay. Just I remove it, not need. Just run the code. When I run the code, our task tab will be running. You can see task tab will be running. Just I click on the task tab and run it. You can see, just click on the run. So now it shows if I face any problem, then it show the red alert. Otherwise, it show the right sign in here. Okay. And it look like that because I not import the visualization in my code editor. So for that, just click on here and then stressing 98% again, and then copy and paste here. Just simply change the mean and max value. Mean and max value. So now this visualization is set in my code. Okay. So when I run the code, I can get the visualization. Okay. And when you export, basically when you export this map, then this visualization is not exported. Okay. We can find out gray color map, gray color NDVI map. Okay. Further, we are using the ArcMap or QGIS and set the visualization from the symbology. Okay. So it will be working. It takes some time. After finishing the exporting, I will show you that again. So now let's check another one. Suppose this satellite imagery I want to export for this study area. Same process. Just simply search here. Export image to drive. Click on here. Oh, sorry. It just, okay. Put the cursor in here. Then click search here, export image to drive. Okay. So now, first of all, image. I want to export this image. And this image is already stored in a variable. Just copy the variable name. This variable name is the L8. Okay. Because when I add the layer of L8, I display this imagery. So this image is stored in the L8. Just I call the L8 and paste here. Okay. Description, you can put anything. I put it, suppose Dhaka image. You can put any name. Folder, you can put any name as a folder. Okay, this folder is automatically created in your Google Drive. I put it, it's a suppose it best. Then it's not need, just I remove. Region is your study area, basically your shapefile variable name. Shapefile variable name is ROI. Okay, just I put here ROI. A scale is the resolution for Landsat 38 meter. Okay, and others not need, just I remove. It's optional, just remove. Okay. So now in this case, this image is created by 3 bands. Okay, it created by 3 bands. You can see there are 3 bands, B4, B3 and B2. But when I print this L8, it show the total 17 bands. Okay, so when I export it, it show the total 17 bands, but I don't need all band. Suppose I need only for the B1, B2, B3, B4, B6, B7, B8 or B7. I need only for this 7 band, first 7 band I need. So for that, you can also select for your specific band. Okay, so let's go try to select. Suppose use the select function. Sometime you need only for the 1 band, so simply put here the suppose B1, then export, then we can easily get only for the 1 band. Suppose I need all of bands B1 to B7, so put here the B1, then put here the B2, B2, then B3, B4, B5, B6 and B7. Just make a list. So now when I export, we are just find out only for the B1 to B7, this type of total 7 band I exported. So now run the code. You can see it show the 7 bands in here which I selected, and now click on the text tab and you can see just Dhaka image, just run. So now it exported only for the 7 images. Okay, already done for this NDVI map. So for that, I want to click on here again. You can see the open in drive. So now it directly open your Google Drive folder. So just download it. You can see just download. Okay. Okay, also Dhaka, this one is also completed. So you can see. Okay, it's also completed for Dhaka image. So I also I can see the click on here or open in drive. Okay, so I keep the same folder name. Okay, so that's why we can easily find out in here. You can see the Dhaka image. So just I download also. Okay, it is done. So now download this imagery. Okay, it also is starting. Okay, after downloading, you can simply remove the file from here. It's not need, just go to trash it. Okay, so now this 2 file you can easily, my god, you can easily open any other geospatial software, ArcMap or QGIS, and further you can also work. Further you can also make the map layout. So these things I will show you that in 5th number class how we can easily work with ArcMap. So you can also try using the QGIS also to display or creating the map layout. It's easy. A lot of tutorial is available in the YouTube. Okay, let me open. Okay, so we find out this type of gray color, you can see. Okay, and further just click on here and add the symbology. Click on the properties and you can see the single band pseudo color, and then choose your own color, which color is prefer you. Just type first. Okay, or any color combination you try to use in here, and further make the map. So this process will show you that further other class how we can easily work with that. And another one, if you check for this satellite imagery which you downloaded, I think some problem, it's not loading just a minute. Okay, so you can see this type of imagery find out in here, and from here you can easily set the band combination. Suppose I put here red, then green and blue. Okay, so now I find out this type of image collection. Okay? And further you can also use the different types of work using this image collection in here. Okay, so this is the process to download the GOT file format and open the ArcMap or QGIS software further analysis. Okay. Okay, any question? Okay, so now talk about the another topic. Okay. So now how I can create the time series chart using Google Earth Engine. So in Google Earth Engine, we create the two types of time series chart. One is for ready-made dataset, another is for unready-made dataset. Okay. So first one is for ready-made dataset. Okay, and another is for unready-made dataset. Suppose you want to create the time series chart. Ready-made. What is the ready-made dataset? Ready-made dataset basically this type of dataset called as a ready-made dataset. Suppose NDVI. In this case, for NDVI or EVI, we are not put any kinds of equation. Okay, NDVI have a equation red minus near infrared divided by red plus near infrared. So this type of equation we are not put in here. okay, or any formula we cannot put. So it's one kind of ready-made data set. So Modis provide you with a lot of ready-made data set for NDVI, LST. Okay, suppose I will show you the one example for this data, trial land surface temperature daily data set, and another is for the 8-day temporal resolution. So this data set I want to use and then calculate the time series chart. But same process can also apply for any other data set to create the temporal chart. Okay, so let's go. So I want to work with, suppose, this data. So this data set, it's a 8 days interval, and this data set provide you the LST day 1 kilometer Kelvin unit. Okay, so this data set we can easily use to monitor LST and also create the time series chart. Time series chart is one kind of ready-made data set, because when we apply the Landsat imagery, then we need to apply lot of algorithm, lot of follow chart or lot of algorithm. We need to calculate emissivity. There is a lot of process when we apply the Landsat. But in this case, if you are using this data set, just you need to use only for this band, then we can easily compute the LST. So it's called the ready-made data set. This type of data set, it already create the band of LST, already create the band of NDVI or NDWI. We are not put any kinds of equation, or we are not put any kinds of formula. So this type of data called as a ready-made data set. Okay, so I will show you the both of data set for ready-made and unready-made, how we can easily make the time series chart. So let's go. So just copy this snippet ID and paste here, and give a name. I put the name Modis data set. Okay, so now this data set have a band. This is the ready-made band. Just use the select function and select this band. This band name is LSTD 1 kilometer. Just take copy and paste here. Okay, so now if I just print how much image in my full data set Modis, just call this variable data set and use the size function. So now it's computing number of images, 1156 images we find out. But I want to calculate this time series chart, suppose for a specific year. So just put here the filter date. Suppose I need this year of 2020, 1st January, from year of 2020 December 31. So I take the 1 year data. So 46 into 8, almost 1 year. So it just we calculate it. So now this is my image collection, 46 number image collection, 46 image collection. So this image collection I want to use and make the time series chart. Okay, so for the time series chart we need to use the function all time. Click on the docs tab and search at UI dot chart. You can see different types of chart. Further let's discuss about the one by one. So in this case we calculate the chart from image. Okay, so UI chart image we need to use it, and under the UI dot chart image we find out the lot of function. You can see UI chart image by class, UI chart image by region, UI chart image by day of year series, day of year series by region. Okay, histogram, region. So in this case I want to make the chart from the image collection. Okay, so you can see UI dot chart dot image dot series. Okay, and if you just click on here, then you can get the description, generate a chart from an image collection. Now I have total 46 image collection, and I want to make this chart using this image collection. I want to plot derived values for each band in this across the image. So this is the function I want to use, and if I just click on here, so now I find out all of argument. So image collection. So this function first argument is image collection. Okay, and I already create the image collection. Image collection basically 46. Okay, so just I call the image collection Modis dataset. It is stored the 46 image collection. Region of interest. You can easily upload your shapefile. You can easily make a point. Suppose this is my study area. I want to check it, make the time series chart for this point or for this coordinate, and it is stored the geometry. I put it's a POI, point of interest. and I simply mention here this is my POI. Okay, and reducer. So in this case, you want to calculate suppose average temperature or maximum temperature or minimum temperature. So just put in here, suppose I want to calculate average temperature. So EE dot reducer dot mean. So now it calculates the average temperature, and scale mainly 1000 meter or 1 kilometer, 1000 meter, yeah. And then it's just X property default we are using here system time start. Okay, system time start. So this is the code always we need to use. So first of all, we need the image collection. When you make any time series chart, first you need the image collection, then you need the region of interest. It can be your boundary shape file, it can be point, it can be polygon, anything. Then reducer, I want to calculate average temperature, so then I put here the mean. Suppose you need the maximum temperature, put here the max. You need the minimum temperature, put here the minimum. So I calculate mean, average. So now this whole things is stored in a variable. Okay, just take a variable, suppose chart, and then store it, and now print this chart. Just copy and run the code. So now it generates the chart. So you find out this type of temperature, you can see, but this temperature have a problem. If you check it, it show the 15,911. So because this data set already have a scale, okay, 0.02, this is the scale value. You must need to use this scale value to reproject the scale value to get the better pixel of LST value. So how I can reproject, we already know about that. So same process again apply. Basically all of images, total 46 images, I want to multiply with this scale value at the same time. Okay, so let's go, we need to create a function. Okay, so for creating this function, same process, just take a variable, suppose scaled LST. Okay, now just create the function keyword, put the element, you can suppose image, you can put any name as the element, and then what I return, I want to return this image multiply with this scale factor 0.02. okay, and this properties I want to apply all of images between this time period, start and end time period. So for that, just use here the copy properties function, copy properties this image, and apply system time start to system time end. Okay, so this is my function. Okay, and this function I need to connect with my collection, mainly image collection, 46 image collection stored in this Modis dataset. Just copy and connecting using the map function. Okay, so now I just use it, and just this is my new image collection, and this new image collection basically reprojected scale value. Just run the code. So now we find out the result. You can see 318.22 Kelvin. It's a Kelvin unit, but I want to convert into degree Celsius. Okay, so for the degree Celsius, just you need to subtract the value, put here the subtract with 273.15. So when you subtract this value, then we can get the result Kelvin to degree Celsius. Just run the code. So now at the degree Celsius result, we find out, you can see the 45.07 degree Celsius, okay, 12.05 degree Celsius we find out in here. So this is the way. Not only for that, suppose I want to need this result for a specific boundary shape file. So then simply import your boundary shape file. Suppose I need this result for Dhaka city boundary. Just click on here. I put it's my ROI, and now I need this chart for ROI. Just I change it ROI. Now run the code. So this is the result for Dhaka city boundary time series chart of LST. Okay, it's the average time series chart of LST. Not only for that, I want to add suppose chart title, X level title, Y level title. So for that we need to add some option. So set options we need to add. Suppose first of all I want to add for title. So put the title LST time series chart. I put this type of title. Then put the Y level, vertical axis. Put the title. It's a LST value. You can put anything. And then suppose horizontal axis. It put the title. It's a suppose time. Okay, just run the code. Okay, it creates this type of chart here you can see, but we find out the line breaking chart. Okay, so it will be it's not the continuous line, because sometime we can see June 1, then June 17, August 12, August 8. So some missing will you also find out in here, 8 days interval. So now I want to create the continuous chart. Okay, so sometimes you face this type of problem, line breaking chart, when you add the legend or when you add the title or X level, Y level title. But if you just use here the interpolation, then it automatically create the continuous line. Okay, continuous line we find out. So how I can apply it? Just apply here interpolate nulls. Just open. Put the true. True means open, false means off. Okay, just run the code. I think some. Okay, just a minute. It's a lowercase or uppercase. Yeah. So now you find out that continuous chart look like that. Click on here. You can easily download the CSV file data. Okay, and also download the photo. Okay, as well as you also add the different types of style of the chart. So I will try to show you that one by one how we can easily create the different types of style and create the chart more better. So this is the basic things for the creating the chart for any ready-made data set. So now you also try to use the other data. You can see it provides a lot of data for different types of data we find out in here, land surface temperature, then also you can see the monthly vegetation data. Okay, you also try. So also you can see the evapotranspiration data, okay, leaf area index data. So you also try to create the time series chart using this type of data. Okay, there's a lot of data, same process when you apply. Okay, all of are the ready-made data. They already create the band, not need to put any kinds of analysis on your satellite imagery, because it provides the directly band of LST. You can see the optical depth or aerosol optical depth. Okay, you can easily use it from the AOD data and also make the time series chart and also create the map. Okay, so now I want to display suppose map. Okay, I want to display the map for distribution, had the high temperature, low temperature, this type of things. For that I already import the Dhaka city boundary in here. So now reduce this image collection. I want to calculate suppose average LST. Just call this image collection 46, store it in here scale LST, because I want to convert the unit degree Celsius and also reproject the scale value. And this scale LST restored the new image collection. Okay, just I copy and paste here. So then I calculate. I want to reduce it. How I can reduce EE dot reducer dot mean. Now it compute the mean result, and then clip with my study area, which is ROI. So now add the layer, map dot add layer, and call the average LST. LST, and then focus on the given study area. Map.center object. Object is ROI. Zoom level 7. So now you find out this type of result without color. So now we try to add the color and display the map. So there are the two ways. We can also add the color from here. Just click on the setting button and you can see the just a stressing 98%. And now add the plated. Suppose low temperature, I want to show this type of blue color. Then I want to show this type of yellow color. Or suppose I put here the green color. Then put here the suppose yellow color. Then put here the suppose red color, or any combination you can use, no problem. Then apply. So you can find out this type of result, you can see, okay, because this pixel size is 1000 meter, so that's why it show this type of grid or cell. So this image you can apply for the big study area, then you also get the more better map. But when you apply it for the small study area, then you can find out this type of grid or cell. You can see it show the grid, not smoothly, not a smooth map, just show the grid or cell. But this same data, when I apply for suppose big study area, like as whole country boundary of Bangladesh, I put the variable name suppose BD. So I want to apply it for BD shapefile. Just clip with BD. Okay. So now run the code. So now we can get the result for whole country boundary of Bangladesh. And now we find out the very smooth map, not show the grid or cell. Just click on here and it's stressing sub 98%. And I add the color. Okay, just a minute. Okay, just a minute. Let me check my connection. Just a minute. Okay. Okay, let me share my screen. Okay, can you see my screen? Yeah. Okay. So now we try to add the color plated for this study area. Suppose I put here for blue color. Greater than use for this type of color. Greater than use this type of yellow color. And for high temperature, show the red color. Then apply. Okay, and further just import. And these things I want to add after the layer name. And put the layer name, suppose BD LST. So now it will be set it. So now we find out that more better map than previous one. You can see it very smoothly map we find out, because it's a 1000 meter and I want to apply it for the biggest study area. So then we find out the smooth map. Okay, but when we apply for the small study area, then we find out so that's why for the small study area, when you monitor the LST, we are using the Landsat imagery. Okay, we need to use here the Landsat satellite imagery. So I'll also show you this process how we can easily apply the Landsat imagery. and monitoring the LST. Okay, so now you can check the temperature. Click on here, suppose we find out this type of temperature. Click on here, it is about the low temperature. Okay, just apply the same process. So you also try to export. And for that, we can easily open in the QGIS ArcMap to create the map layout, other things we can easily available in the Google Earth engine. So you also try and also create the time series chart and also create this type of map. Okay. Okay, so any question you can ask me, please. Okay, so just we take the break for 10 minutes, then we'll start again. Okay, just make a break for 10 minutes.